of each of the Hemi, Bitcoin, and Ethereum chains that ZK proof operates over is recent compared to the time that the ZK proof is actually being validated. And that you can do on Bitcoin. You can't do it directly in a Bitcoin script where the script, looks at a timestamp and then compares it. But you can do it with that disprove time transaction, which again burns that same assert connector output, which lets you basically say if the ZK proof that the operator committed to as part of that they're going to commit to a timestamp with a Lightning Port Winternet signature. And then if that timestamp plus a certain delta period of time for the protocol to run correctly, if the current timestamp is over that, then we're allowed to spend the connector output. And you can do that with enforcing a absolute time lock over that, or you can also do it with relative time locks too. But a little off topic there, but that's the kind of detailed summary, I guess, of how the system works. So it's BitVM2 technology, but replace the Superblock Light Client emulation system with a better construction that makes the ZK proof self-contained, so you don't need the Bitcoin self-introspection that Superblock Light Client emulation was meant to get around. And then you were basically still reusing the same BitVM2 style verification mechanism. So the same idea of taking that Groth16 verifier, chunking it out, having the operator commit to the initial input into the verifier script, as well as the intermediate mid states between each of the chunks of the program. And then that lets you enforce an optimistic verification of a ZK proof on Bitcoin. Hopefully most of that made sense. And again, we're going to really deep dive into it and get into a lot of questions on the HBitVM AMA next week. So if you want to learn more about it, definitely join us for that as well.
All right. Let's move on to our second question.
And a vote for Josh for getting more coffee.
All right. I think did we just have next week's AMA?
No, next week's gonna be better.
Right, right,
But
right.
since this is the
Wait,
building,
longer even?
we'll see. But since this is the like office hours, builder focused. One of the cool things I do want to call out real quick with the all the work we're doing for HBitVM is that while we're using it for our tunnel construction, and again, people have heard me mention this before, but this is very relevant if you're going to build something cool on Hemi with Bitcoin. That same ZK HBitVM proof system that we're building, you can remix that with very minimal changes and then use it for other sorts of applications. So you can think of the HBitVM proof system and this the Bitcoin transaction graph to verify it as sort of this generic flow control of the flow of native Bitcoin on the Bitcoin network contingent on verification of ZK proof. So there's a little bit of more nuance there because you do need to change the way that the Bitcoin transaction graph set up and the participants in it, depending on what kind of protocol you're building. And there's some other gotchas for certain types of protocols that you have to think through. But generally speaking, if there's something that you want to control the flow of funds between participants using real native Bitcoin, using ZK proofs of anything from Bitcoin, Ethereum, and or Hemi network. So Hemi network could be where you have like coordination contracts that implement the business logic to decide who should be getting the Bitcoin in a specific instance, say for, a loan liquidation or exercising of, on-chain options or whatever. If you want to build something where you want to control who gets Bitcoin based on verification of a ZK proof on the Bitcoin network, there's a good chance you can reuse this HBitVM proof system, remix the Bitcoin transaction graph a bit, build the right business logic into contracts that you put on Hemi that use HBM for Bitcoin observability if you need that as part of your protocol's operation. And then you can basically have ZK settled fund flow control on the Bitcoin network natively. And again, there's nuance in there. If you want to build something around that, reach out. And if you have a specific idea, happy to dive more into the specific nuances that affect that use case you're interested in. But generally speaking, it's a pretty self-contained primitive that you can port and do other cool, truly Bitcoin native DeFi stuff with. So with that, I'll throw it back to Rick for question number 2.
All right. Oh Jesus. Here, okay. This is gonna be a mouthful. All right. What do you think about this approach? I think about this for the new Hair Games design. Please suggest some other models if you want to share. When a Hair Games new game level ends, raw game telemetry is sent to a secure node.js backend, which validates the data, calculates the score server side, kills 100 points, and cryptographically signs it off chain using an Ethereum private key with zero gas cost. The player then submits this signature to the Hemi smart contract, which uses native ECRecover verification and sequential mapping nonces to confirm the backend's authority and prevent malicious replay attacks before updating the on-chain leaderboard. What do you think about that? I'm gonna post that in chat because
Yeah, if you could post that, I think it'd be a little easier.
I'm gonna go ahead and post that.
Sorry, give me one. I'll be back in 30 seconds.
All right, Rick, that was pretty funny.
Hey, I read what's written. It's not my fault.
Going forward, I will call it ECRecover. This is
Yeah,
going to be part of
I am
the
good with that. I'm good with that new naming.
Yep, it's just better.
All right, sorry about that. Okay, so you posted the question in chat.
Yeah, so we have a new primitive called ECRecover. So I need you to
Well-
explain that first.
Well, what's it? That's what it says. What's
I'm going to rephrase that as verifies a signature.
No, I need to understand this new ECRecover primitive.
EC recover. Basically, it lets you recover the public key from a signature and a message.
I think you kind of missed a joke here, Max. We're making fun of Rick.
Oh, okay, yeah, I was gone for 30 seconds, so I think I missed a
We're
word in
making fun
context.
of we call it EC instead of EC. That's all.
Oh, it's ECK recover. It's EC recover, but it's cool with a K.
Yeah, take that, Marco.
Well, I need to understand what the cryptographic primitives are behind the cool part.
It 1 in 100 times it gives you a false positive.
All
It
right,
introduces some fun
Kind of
randomness.
like Debian random.
Yep. Oh man. All right. So for the actual question, let's see. Just some other models here. Okay, so the game level ends. Game telemetry is sent to a backend. Validates the data, calculates the score. Blah blah. Signature. I think overall that's probably the right design for this kind of a thing. This is kind of where on-chain gaming becomes difficult. So there's some things blockchain's really good at, which is, keeping track in one version of history of a ledger that everyone can interact with and see. But for things like games, a lot of times, just the latency of a blockchain itself is way too much. You can't have a first-person shooter where the packages are sent as on-chain messages, right? And you'd be stuttering around the map, moving every 3 seconds, and it'd be a nightmare. And also just the cost of doing that would be absolutely insane. So for most game applications, you do need some way for you to run some sort of backend that does basically runs the game, quote unquote, business logic engine or whatever you want to call it, that these players did these things, they made these updates to global state, here was the result, this player is dead, this player has plus 100 points, whatever, and then sign that and put it back on chain in some way that can be useful for releasing funds or transferring, minting in-game assets that they won as part of a round of a game or something like that. So overall, that's probably the right approach. The hard part is the game telemetry part. Like, that's always going to be a vulnerability potentially where somebody can manipulate the game telemetry that's sent to your backend. So,
That's the key. How does the back end know that that the data it got from the front end is real?
yeah. And so a lot of this comes down to what the specific game is doing. So, for example, to do something, a really simple example would be a game of chess, right? Each of the moves has rules that can be validated, and you know that a player can only do one move per turn, and they can do these moves with these pieces. And so, you can have the back end running that basically receives those messages, and the user can optionally sign them if you wanted to be extra safe to make sure somebody couldn't man in the middle attack the chess game or something. But things like that are very easy to do and verify in the back end. And then there's still some trust of obviously people playing the game are trusting that the back end is honoring the data that they send to it, but the back end doesn't have to trust the front ends because the front ends are just reporting which of a set of valid game operations a user played. For something that's more like, an arcade game where you say you take something like Galaga and then implement it, and then the front end's just at the end saying, hey, this person scored 20,000, and sending that to the back end. That's super easy to manipulate. So somebody could just submit a different score and say they scored, 10 trillion points, and the back end has no way to verify it. And the only real way to verify something like that, and even this isn't perfect, obviously, but would be, if you captured every keystroke and interaction with the game, and then were able to re-simulate those on the back end to replay the game as the player played it, and then see what score they would get from doing that, and then assign them that score on the back end. And again, that's a ridiculous amount of engineering and still doesn't fully solve the problem, but it would certainly make it harder. But so yeah, it really depends on the type of game, the types of things. Yeah, and Joshua, secure and Node.js should not be used next to each other. Very fair point. But Node.js security aside, it really depends on again exactly what kind of game you're creating. But if it's the kind of thing where either the user streams interactions real time to the back end, a la a chess game or something, or records all the interactions, and then you can replay and re-simulate the game on the back end, that's probably the best design you can realistically get. And if you implement the entire game logic in that way, where you could say, users playing a game of Galaga, and they held from the start at 0.3 seconds in, they held the left arrow key for 1.2 seconds, and then press the space bar once, and then, XYZ action, action, action. If you can actually write the game in a way that you can replay that interaction and get the exact same result every time. So again, no randomness, or if you're doing randomness, it has to be non-random randomness. But then you could actually ZK prove that game and then post the ZK proof of it on chain. So there's still some trust in the back end that it's going to actually produce the valid ZK proof and that it's correctly representing the player's actions. But if you had the player sign the package of their actions, you could have the ZK proof validate that this player with this public key signed these interactions, which when simulated in the game engine produces this output. And you could actually ZK prove all that and put that on chain. So that'd be the crazy version of it. But again, I don't think that's really practical. In most cases, yeah. John, do you have any sort of mid-state practical version of this?
I was going to say, well, for one thing, I was impressed that we started out talking about Galaga and we ended up talking about ZK proofs, which is definitely something that could only happen here. But other than that, what I was going to say is it actually depends on, just how accurate do you need to be? In the sense that if you need perfect trust, then no, it's almost impossible. But that's not to say that you can't have on the back end certain rules that would say if you're okay with both some false positives and some false negatives, you can do things like say, force the game, have the game client sign, this is the start date, this is the start timestamp, this is the end timestamp, this is the score. And then you can say, well, oh shit, this is a score that's not plausible in that time, I'm going to throw it out. And that's like probably a silly example of it, but there are other things you can do like that. And it's all about just, if for things that are not financial, you don't need to be accurate every time. If you can, it's just like games, there have been a lot of great games that have shitty hit detection, and it doesn't make them bad games. It just means that sometimes you're going to be pissed off that it didn't work right. If you're okay with being pissed off that sometimes it doesn't work right, then you could probably come up with some mid versions where you where you know something about what's going on in the client, but not everything. And you can say, well, this is probably okay, or this is almost certainly not okay, or other variants of that. So if statistical is okay, then you have options. Generally, like the sketch of the method you were saying before is the right one, though. You know, where you have the quote unquote trusted backend. And I share Joshua's thing that trusted and JavaScript do not go together. And I wish I had some. Oh well, I don't have a good example for two other words that should never go together, but trusted and JavaScript are them. But still, you know, having the backend that you mostly trust. Well, Marco, I mean, hell, Tetris is even in the, you know, it's even in my text editor. So when I use Emacs, there's, you know, meta X Tetris mode. So
Is that like the 1990s version of the brain rot TikTok side screen with your IDE?
pretty much.
Alpha, I think even the team members who write JavaScript are not huge fans of it. I'd go with a solid most to all. There's one or two that maybe don't hate it and just have a strong dislike for its dependency management.
So this is where I wish I could write a formula where it approaches zero over a, you know, for a long time.
As the amount of time spent developing software increases, the probability that you'll hate JavaScript goes to 100.
Yeah, something like that.
Oh man.
It approaches zero, but it's never zero.
All right, we got two more questions on deck. One from no one. Hey guys, so I just deployed my first contract in Hemi. Congratulations. And for now, the only supported token I have is ETH. I was just asking if I can add the Hemi BTC token the same way I did the ETH, or is there anything else?
So it depends on how you added ETH. So what most people do when they write contracts that handle ETH and other assets, they'll write it to work with ERC20s. And so you're not actually interacting directly with ETH, which is like the native asset, the value field and transaction, stuff like that. But you're interacting with a wrapped version of it, which is fully trustless. It's just, you stick ETH in an ERC20 container so you can move it around and treat it like an ERC20. Then you can pull it out at any time with just interacting with the contract. So if you built the system to work with WETH or wrapped ETH as an ERC20, then it's super easy to just add Hemi BTC as another ERC20 asset treated exactly the same, or the Hemi token or USDC, USDT, any ERC20 token on the network, you can just drop in as a functionally equivalent version of what you're doing with wrapped ETH. Obviously, there's things to consider with depending on what kind of a protocol you're building for multi-asset support. So if you're doing something that needs oracles, then you need some sort of oracle mapping for each ERC20 to the oracle or oracles that you're going to use as the price source for those. Or if you're doing something where different assets could be used for just making it up to play a game, you need some sort of pricing in each of the assets or something like that. So there's going to be as you go from one asset to more than one asset, or maybe depending on what you're doing, other logic that you need to implement that treats each asset individually in a certain way, or has some sort of mapping for, we do the same logic with each asset, but we do it with different data for each asset, like, different price speed, things like that. If you just wrote it using native ETH, which most people don't do because it's harder, and again, you don't have this adaptability to swap in other tokens and use them in the system. But then if you did that, you need to convert it over to using wrapped ETH, and then your architecture would be generic, and then you can use any ERC20 in it. Technically, that's not true. Some ERC20, you can implement something that you can write a smart contract that implements the ERC20 interface and then does really annoying stuff. Like you could make an ERC20 that implements the interface, but on every 100th transfer, it randomly burns the tokens that are being transferred or things like that. So that's why usually, again, depending on what protocol you're building, but most people don't, have a protocol that's open to any asset, or if they do, it's jailed in a certain way where if that asset behaves badly, then the damage is contained to just the people interacting with that badly behaving asset. So that's also another thing to consider if you're, making a perps decks or something, you'd want to make sure that people can't just list any random token and then somebody can list a token that, burns on mint or burns on transfer or charges a fee on transfer or something weird like that. But generally speaking, you'd have a list of approved assets that all implement the ERC20 interface, and then as long as it's on the list, it can work in your system and you can treat every asset the exact same way. That was way longer of an answer than it should have been for that question. My apologies.
Alrighty. And to close out the session, we have one more question. Which framework do you think is better for smart contract development, Hardhat or Foundry?
We use both. I personally use Hardhat just because I use it more, at least because it's what I started with and I'm familiar with. So that's I don't really have a strong opinion. I don't know, John, if there's
I mean,
some features that are different between them that, depending on what you're doing, like I think Foundry set up for doing simulations and the way that their tests are written are a little easier, and the tests are a little easier to make like sort of generic reusable components that you use in your tests, but you can do that with Hardhat too. It's just a little more of a pain in the ass with how they type some of the stuff.
I think I'm sort of in the same place where I've used Hardhat more because it's just the one that was there when I was, doing this originally. But it sort of feels like Foundry has kind of Foundry seems to be the one that gets more of the love now. That's the direction most people have gone. So if you go and find a random project that's not old, there's a much better chance they're using Foundry. So if I was doing something new, I would probably use Foundry just so I'm not swimming upstream in terms of that stuff. Do I like either of them? No. But what are you gonna do?
One of the annoying things with Hardhat when they went from V2 to V3, they changed a bunch of stuff that basically broke, I don't know, like 80% of the tests you wrote in V2.
Oh, that was so goddamn annoying. Like that, because that's really what you should do when there's a new competitor on the scene that, is already kind of, gaining ground on you. Make a totally backwards incompatible update. That is never backfired.
Definitely how you win hearts and minds of developers. Actually, to be fair to both, I'll complain about Foundry 2 for a second. We had so part of the Hemi network deploy scripts for deploying the contracts, upgrading the contracts, all of that. Those use Foundry, and I can't. This is like a year and a half ago, so I can't remember exactly what the issue was, but basically the recommended way to use Foundry is just basically Foundry up, and it downloads the latest versions of all of the components of the Foundry toolkit, and that there were several times that there was a like newly released build that Foundry up would download and it was broken, it wouldn't compile a contract correctly, or there was some other issue that we were running into as well. So we'd have this, end-to-end deploy system that we test and everything works right. And then we wake up the next day and run it again and it breaks because it's downloading a new Foundry version. And then you try to pin the Foundry versions and then it gets angry about that because you're like, well, I know this version works, just keep using it. And yeah, I don't remember the exact issue because it's been a while, but that was, if Clayton was on, he could probably regale us with war stories from that one.
Also, it annoys the hell out of me that to use Foundry on, so I try to, if I'm going to use AI, I will only do it in a container. And if I'm going to use something I don't trust, like Node or Foundry, I'm going to do it in a container. And I usually tend to use Alpine Linux for all those for the base of all those containers because it's, small, doesn't have too much crap, is nice for, CI type stuff. And Foundry and Alpine Linux are a colossal pain in the ass. And I know you can kind of blame Alpine for using Muscle and not using a normal damn C library, but still, it's there. And Foundry, you need to build it from source, and it takes just forever. And it's much more of a pain than there's any reason it should be just to, check that a contract works.
And also neither of them have, and again, this is the stop calling the kettle black. We need to work on our own documentation too. But I've never been. Whenever I go looking for something in their documentation, I usually get lost, and it takes way longer than it should to find something relatively simple.
Yeah, I think I'm not going to complain about that one.
But yeah, we have the same problem that we need to fix on our side, so I totally get it. But I see Joshua's strongly advocating for Go in the chat.
Yes, he has been vehemently for a good 15 minutes now.
I think at this point, the only reason I wouldn't use Go for something is if it needs to run in a ZK VM, because all the tooling there is built around Rust. But yeah,
One day I'll rewrite it in C. Just to not have to deal
hopefully.
with
I
the
mean,
work.
technically, the ZK VMs it's just running a RISC-V binary, and so anything that
Which
targets
you can
LLVM.
compile with Clang, which is part of LLVM, which is what Rust is doing.
Yep. So technically, the ZK proving system itself would work fine, but you're missing all the nice sugar and the ecosystem around it for.
Oh, we can just
how data
transpile it
gets-
using Claude. What could ever go wrong?
Nothing, absolutely nothing. But yeah, I would like to revisit trying to get some Go stuff to work in a ZK VM at some point. But yeah, realistically, for now, all of the like patched, accelerated cryptography libraries that use the ZKVM precompiles, those are all Rust crates, right? So it's, it'd be trivial to get like, hey, we wrote a program that adds two numbers together and outputs the result. It'd be easy, probably be not that hard to write that in Go and then compile it to RISC-V and then run it in a ZKVM and figure out, some data serialization to feed the right stuff into the VM start state and whatever. But once you start getting into using the ZKVM precompiles, which are their own patch crates in Rust, and then you have to like create a Go version of that patch that calls the right, system call or whatever the ZKVM uses to implement the accelerated custom circuits. And that's where not only is it hard to do, but it seems like the area where it'd be really easy to make a mistake and screw something up. There is one project doing I haven't checked on them recently. They were doing a ZKVM that was all built around the Go ecosystem, though. But last I checked a couple months ago, it was still in very early pre-production state. Can't remember the name of it. I have it bookmarked on one of my Brave browser sessions on one of my computers somewhere. And yes, John, we'll make a Fortran 77 ZKVM.
All right. I am
And
not
Josh
seeing.
was throwing around false accusations. I'm not a Rust advocate. I'm a reluctant user of it for ZK stuff.
Oh, Josh is just besmirching people in the chat now.
Maybe this is why Discord doesn't let him talk on the
Exactly.
Oh man.
All right. Well, we are right about the top of the hour. I'm not seeing any other questions coming in that Joshua isn't answering with the answer Go. So we can probably wrap this one up. But thank you all for attending. We did see the poll results. It looks like we're gonna keep this alternating schedule going for a while. Please say best programming languages C. I don't have a strong opinion on it. The engineers can fight with you over that, Alpha. I'm not touching that. All right, but thank you all so much for joining us. We will see you at the HBit VM AMA next week, as well as Midweek with Max, as well as the Built on Hemi series that Jeremy has going. I believe that is that this week or next week? I want to say it's this week.
I think it's this week. Yeah, that sounds right.
I feel like it's this week at 3 p.m. EST. There will be an announcement, but regardless, you can catch us at all of those places, and of course in Discord. So, with that, thank you all so much, and we will see you at the next one.
Actually, just while we have people here,
Oh, sure.
I know we did the poll for timing, but are there a lot of people here who like attending these who would not be able to attend afternoon sessions. Because we have a much bigger turnout today than we did last week, so I think it's fair to poll this group and get a maybe slightly biased response, but if anyone vehemently disagrees. Yep, I remember that textbook from college.
And yet, oddly, the worst computer textbook, Numerical Recipes in C, is a C book. It's Numerical Recipes in C, because they took numerical recipes in Fortran and they redid it in C, but they wrote a whole bunch of weird shit so that all the arrays in the examples started at 1 instead of 0 to match up the Fortran. So they do all sorts of insanity to make the code work.
That is horrifying.
I still like shudder thinking about that book.
Someone should write a C textbook for how to implement the JVM in C, so then you can write Java code. I think most of the JVM implementations are
Pretty
actually
sure
C
that's
and
how it
C++.
started.
Yeah, I know the original one was
I think
Either-
the
I
very
think
first
C,
one was
right?
C, and then they ported that to C++ for extra slowly. So they needed to rub some potato on it.
Okay, we need to write a JVM in Rust now then.
Yeah, you do. And then we need to write Rust in Rust.
I was going to say, can you really trust any programming language where the compiler is written in something other than either the language itself or C?
Nope. I think this one's pretty easy. Just at the hard now.
You don't want a Java program that generates the C code for the compiler?
We've seen that in the past. Meta actually did a bunch of that.
Oh
They,
god.
yeah, I'm not kidding. So in order to make JavaScript faster, they actually transpiled stuff to C++. It really was quite a thing.
Well, I think with that disappointing knowledge, nobody's
Well,
expressed.
let's make it more disappointing. So show me a line of Rust code that has not been written by Claude in the last 6 months.
Whatever Josh was doing.
Well, but Josh is a single guy in a country you cannot even pronounce.
Striliet.
So yeah, it's people are very excited about Rust, but nobody is realizing that everything is being rewritten in Rust using Claude instead of humans. So we're going to pay a price for that at some point in the future.
I was also telling John this is a very N of 1 limited test case, but I was playing around with Claude to see just if you don't give it many instructions, kind of the defaults that it does for stuff. And for pretty much anything that you could do in Rust, it does it in Rust by default. Which is not surprising, but it was interesting to actually see that in practice. If you just say write a program that does XYZ and it has nothing to do with web, Claude's going to write it in Rust from my my little fun experimentation. All right. Well, no one's vehemently opposing the alternating schedule, so I think that's the lack of response is a response to my follow-up survey, Rick.
I also take the no response as a response. So so we're rotating. We'll be back at it's 4 p.m. EST EDT next week.
All right, perfect. So we will see everyone on a mixture of midweek, this engineering call at the 4 p.m. Eastern Time alternating schedule, and the HBitVM engineering AMA, where we'll go into more detail than we did today.
I can't wait for that. This was the abridged version.
Yeah, it was a good question.
It was a very good question. It was a hell of an answer too. So good, in fact, that we're having an entire AMA regarding it next week.
Perfect timing.
Exactly. All right. Take care, all. Thank you so much for joining us, and we will see you soon.
All right, appreciate everyone coming out, and we will see you next week.
All right, bye.
Thank you all.